So today we're going to be working on the electrical system. We're getting ready to install that propane furnace I was given, and before I can put that in, I do need to do some updates to the electrical system because there's no place to plug it in. So that's what we're going to work on. So I didn't catch any of this on video, but I did build a upgrade for the back of the van here. So this is under the bed. It's a complete shelf here over the wheel well for the electrical system. So this is where all the electrical stuff is going to be installed, right here. Underneath there, I'm going to install some insulation, stuff like that, and then seal it up so the wheel well will be nice and insulated. But I'm going to be doing some electrical upgrades in this space. I got a 6-way fuse block. 12-way would have been better, but the 6-way actually fits better. And I'm going to install it right here on the shelf, the back of the shelf there. I've got a couple bus bars that will be going towards the back that will hook up to the battery system, and we'll be able to distribute the power out. It's going to go, see, the fuse block is going to hold primarily all the 12-volt appliances and stuff. Furnace, refrigerator, roof vent fan when I install it, all the 12-volt lighting I'll be installing, things like that. That's what the fuse block is going to be for. The ham radio equipment is going to be on its own separate fuses and own separate wires to the bus bar. Bus bar is going to have 4-gauge wire feeding it. Probably could go bigger if I wanted to, but I think 4-gauge is good enough for what I'm doing. I'll eventually pick up a 700-watt power inverter. I'm going to fuse the whole system at 100 amps right now, so we can't draw more than 100 amps for the whole system. It's very unlikely I'm ever going to get anywhere near 100 amps current draw at any given time, so even with the 700-watt power inverter, I doubt I'll hit 700 watts on it either. But if I ever find a need for it in the future, everything's going to be built to be fairly accessible. I'll just have to pull everything out from under the bed, and like I've done here, and we'll be able to get at all the wiring and replace it if I need to put thicker gauge wiring in the future. Again, I don't think that's going to be necessary. So the first step, though, we're going to get the fuse block installed right here. So, so the only downside to installing the electrical stuff down here is I have to crawl under the bed to get at them. Luckily, once it's installed, most of the stuff is stuff I shouldn't have to access too often, though. The fuses are going to be out here where they're easy to reach. There'll be some more stuff in the backside by the batteries, which will also be able to easily reach from outside the van. But over here as well, the main electronic stuff is going to be housed. And a bit of effort to get at it, but it's doable. Anyway, these are the bus bars I picked up. One black, one red. These are going to be installed in the back here. Like that. That's why I tucked it out of the way. It'll be installed here. I was thinking maybe install one up there, but I don't know. Might be a good idea because, let's see, the fuse panel, the negative is on the top, so it'll be more accessible to the negative side. I don't know, though. Also going to block off some of the wiring. I can also put them in here and just stagger them off a little bit, maybe. I don't know. Not sure what's going to be best here. Yeah, I think down there like that, staggered. I can even just install them side by side. There's enough room. Interesting. All right, yeah. You can do that. Put them in side by side. Just enough space for it. Well, this one's sticking off the edge a little bit too much. No, that won't work. Okay. Nope. I don't know. Let's figure this out. Anyway, of course, you've got a big pole right in the middle of it, so you can't see it anyway. So this is what the bus bars look like under the covers. As you can see, it's got 3 heavy-duty posts, and it's got 10 screw holes here for these little screws. These are smaller posts for smaller current applications. So we'll put that in. Put those all in there, and we've got all set up there for smaller current stuff. So I'm going to put the main power feed to each of these to the center post. That'll come off the batteries. One side of the post is going to go to the 700-watt power inverter when I get it. The other set, well, I probably go to the fuse block. And then the smaller ones are going to go to, we'll have things like my ham radio equipment, all the battery charging system, solar panels, alternator charger, all that stuff's going to go into the smaller screws. And this will distribute out all the power as needed to the whole van, basically. Okay, so I got the bus bars installed back there. I didn't show it on video because it was just too tight a space crawling around under there. So it was just easy to get them installed and done. So next we're going to get the fuse block installed. Alright, so this is where the fuse block's going to go. Keep it up high here. Eventually there'll be a top over this here, so I'm going to leave the area below here for wires to run through. But this is where it's going to be installed. I'm going to mark off the 4 points where the screws are going to go through, if this pencil's even reach. I don't know if it will. Let's see. I think it will. Yep, we got it. All right. Friendly. Okay. What we have to do is get it lined up to the hole. It goes right in. Okay. Hopefully we drilled these right and these just all go right in. That. There we go. One fuse block. And I just got to do the wiring to it. Okay, so I've been doing a pretty terrible job of this YouTube thing. I've done quite a bit of work on the Wolf Van Jack here, and just didn't pull the camera out. I just didn't bother because I had to... Well, it's been probably a couple of weeks since the last clip you just saw. And since I have to keep the van parked at a remote site, it makes things difficult because I have to go pick up the van from the site, bring it home, do the work on it, and then at the end of the day bring it back. So it means that a lot of the times when it's pretty much after I've done my regular work type stuff, which is my IT support stuff that I've talked about before. So I get a couple hours of daylight to work on it, and that's about it. And that's kind of the case here. So I just want to try to get as much work done as I could. So I thought I'd bring you up to date on what I've done thus far. And as you can see, the van's kind of a mess here. I've been moving stuff around, shifting stuff, things like that, trying to get it ready here for this build here. But I've made a lot of progress. As you can see, the lights are on. That's a huge, huge improvement right there because I had the whole electrical system torn apart. Started rebuilding it all from scratch here. And it was off for a better part of those 2 weeks. I couldn't even turn the lights on. So I'm glad I have that back up and running. And I want to show you some of the improvements I've made. First, one of the biggest things I've done. I've added a battery monitor to it. Now obviously this is going to be mounted in a panel someplace, probably in a cabinet. I'm thinking of putting a cabinet here and have all the things like this, the thermostat for the furnace, my solar charge control, all that mounted right here. So I can look at that stuff at a glance. But as you can see, let me shut that light off. You can see all kinds of, there we go, almost had it. Well, this camera doesn't do a very good job of showing it, but this thing's showing all kinds of statistical data about the what the furnace is doing here, but it's pretty hard to see. Let's see if we can turn the brightness down. Maybe that'll make it easier to see. There we go. Now you can see it. All right. Yeah, beep. Uh-oh. Seems I broke it. Not sure what I did. Okay. Unplug it, plug it back in. Yep, I broke it. I do. I'm gonna shut the backlight off. All that data's correct. Oh, I think I know what I did. I know what I did. I told it the battery was dead. I'm going to press and hold the up button. There we go. Alright. We'll recalibrate it later anyway. So you can see it gives a whole bunch of... I can't believe I did that. Right on camera too. So hope you guys found that interesting. Entertaining here. So estimated capacity of the batteries. Percentage of the battery life, again, estimated. Let's see what else we got down here. Voltage, 12.7 volts. Which I noticed this reads about 0.2 volts higher than the voltage reading on my solar charge controller. So I took out my trusty Fluke 77 and confirmed it, and this is the one that's accurate. Which actually means that I've been trying to keep the voltage from dropping below 12 volts for a while, and I've actually had more capacity in my batteries than I thought I did. So that's a good thing. This means I can go longer on a charge than I thought I could. So we got the voltage. We got the current draw, which is currently about 1.2 amps to drive the lighting in here. So I notice if I'm running the power inverter without the lights on, if it's just about no load on it, this thing's still drawing 0.6 to 0.7 amps. That's a lot of power loss for doing absolutely nothing. So I got to remember to turn that power inverter off when I'm not using it. Unfortunately, I still have the AC powered lights inside the van. I haven't bought the 12 volt lights, but anyway, you get that. You got the wattage. You got a little timer that's reading out how much time is left. It's estimating at the current power usage how much time is left right now. You see it's 99 hours, 59 minutes because that's the maximum it can read with a 247 amp hour battery system. And I'm just drawing 1.2 amps to run the lights. It's not going to be a huge load on the system, so we'll have more on that as we get that installed, and we'll get through that. Let's turn the light back on here so you can see me again. There we go. So that's that part, and I'll show you some of the electrical system upgrades I've done. Cover off there. We got lots of room for fuses, so we're going to be setting up, let's see, we're going to have fuse for the lights, fuse for the furnace, fuse for the fridge. So basically all the essential stuff that runs the van is going to be connected to the fuse block as we go along. That's still my old charge control. Again, that's going to be mounted up on a cabinet. If you're wondering what that green thing is in here, that's a DC to DC charge controller. That actually was originally in the Wolfinier, the original camping setup. That takes power off the alternator when it's running and acts as a 20 amp charge controller. You see that little box behind it? I don't know how well you can see that, but that's boy, it's tough to get this in here. See if we can get in a little bit closer. You can see a little box behind it anyway. That's an older battery isolator I have, West Mountain Radio. Yes, it's a ham radio product, ISO power. It's designed for its intended use to connect up to the starting battery, and then it will have a secondary battery hooked up to it. And basically it's just a voltage switch. When the voltage goes above 12.6 volts, it turns on. When the voltage drops below 12.6 volts, it turns off. And I would actually connect or disconnect the battery when it turns on and off. But I'm just using it as a power control for the 20 amp charge controller. So that's actually fed off of these wires over here, which piggyback on the main power input. And it's got a feed point back to the other side that tells it that it's got to turn on when it's time. Because this doesn't have any sense other than just a wire that you feed 12 volts in to tell it to turn on. So when the engine starts, the alternator spins up, the voltage on the starting battery goes up to above 12.6, and that thing starts charging. At some point here we'll install the power inverter and an AC charge controller. So when I'm plugged into the grid there from someplace where I have AC power available, I can plug that in. That'll also charge the batteries. So that's what I'm working on back here. Let's move to the back of the van. Okay, back here, got all the batteries. Built a couple of nice sturdy shelves here to store things on. while protecting the batteries. Each battery has a individual cable going onto it. Each battery is fused, 25 amp fuse on each battery. I can disconnect any batteries. Right now this system's actually wired with 4 power points to connect up. If it's actually wired so I can add in 4 100 amp hour lithium batteries at some point in time in the future when I have the funds available to do so. But right now I'm still running the 4 38 amp hours and the 1 95 amp hour. That's where I get the 247 amp hours from. So each of these just runs the system here, and they're all just wired in parallel. This side, and there you can sort of see a little bus bar, with the positive and negative side bus bar back there in this cover, under this cover here. That hooks these 2 batteries up and then connects to that big heavy yellow wire I used to have going right across the floor. I actually cut out a gap under the subfloor, so it's actually underneath here now. You can sort of see it coming down inside there and goes into the floor. It comes up on this side, and that's what bridges the power from those batteries over, feeding these batteries here instead. Now in here we did things a little bit differently. Let me see if I can pull this battery out of the way a little bit here. Well, that's a 100 amp fuse. So you got the 2 battery wires from the 2 batteries going into that, plus the heavier gauge wire from the other side. That goes to the 100 amp fuse. So that's the master fuse for the entire electrical system. So I can't draw more than 100 amps. Behind that, a little difficult to see back there, I know, that's the shunt for the battery monitor. So all the negative electricity goes to that, and you can see I've got the 2 battery terminals from this side hooked up to that, plus the other side of the yellow wire. That's running the shunt, and there's some wires coming off the back that feed up to the meter. And that all connects into a couple of bus bars back here, the master bus bars. That's one of the covers because I haven't been able to get it back on. I'll talk about this cable in a minute too. But there's a positive there, ground is there, negative I should say, not ground, negative. That's where everything for the electrical system is going to originate. If you can see it back there, there's another fuse back there, another large fuse. That one's 40 amps. That's going to the fuse block, so the fuse block itself can't draw more than 40 amps across everything, nor should it ever do that either. Again, these just storage shelves, and that's the electrical system in a nutshell here. So that's what I've got set up here. One thing I'm not so sure of was the brightest idea, is mounting the all the equipment in here. So it's very tight space to get into. Thankfully this is stuff that if everything stays working right, I shouldn't have to access it too often. But you just never know. If I blow a fuse or something, it's going to be a pain to get at it, because I'll have to empty everything out of the back and climb back there. Luckily the fuse block itself is pretty accessible, but just to show you what I have to go through to get inside there. I actually have to lay down and crawl in, like this. I can work probably one-handed to get in there. Most of the time it's really difficult to get both hands in there. So not the best solution, but just gives me more of an incentive to make sure my power draw on the system never exceeds the capacity of the fuses. So anyway, that gets you up to date on the electrical system. My next big project is going to be installing the furnace now. We've got the electric, so I had to get that done before I could put the furnace in, because it's just, I was out of places to plug the furnace in, and that system was just a fire hazard on its way to happen, because there's just lots of things that needed fuses and didn't have them. Even including one of the 5 batteries didn't have a fuse on it. And I had to fix that. So that's been corrected now. Everything's fused. In fact, some of this stuff is going to have to go through multiple layers of fuses before it finally reaches the batteries too. So this is a much safer system. So that wiring harness you saw back there that I moved out of the way, I meant to talk about that, but that's the power cable for the alternator charger. So that harness originally went to the rear AC and heating unit that was back there. That ran the fan. It's got this nice heavy gauge wire that goes from there all the way up to the front fuse box inside the van itself. It has a nice big heavy duty 50 amp fuse on it. So I modified the harness from it and hooked it up to that DC to DC charge controller. So it's actually drawing power off that port, because it was there already. The wire was right back to that corner, right where the heating and AC unit used to be that I took out. So I took that over, and that's going to power the alternator charging stuff. It saved me from having to run a wire up to the front battery and stuff, like I thought I was going to have to do. So that was great. That was a great solution to that problem. So if you got a van that has the heating and AC wiring harness in place, and you want to hook up batteries to it, batteries in the back corner there to charge while the alternator is running, that's a perfect solution. Just don't hook the batteries directly to it. Make sure you get a charge controller. I'm probably actually going to change the fuse on it, because it has a 50 amp fuse, but I'm running a 20 amp charge controller, because the alternator, that's about pretty much all the alternator this van can support. So I'm going to go out and probably swap that out to a 30 amp fuse. So that should keep the circuitry a little bit better protected. So anyway, like I said, the next project is to get the furnace going. So I'm going to try to get that going as quickly as I can, while still not doing anything that's going to be unsafe with it, because I am going to be setting up a propane burning device inside the van. So I want to make sure it's safe to run. Once I have that up and running, a later project will be to build a propane locker so I can safely store the propane in the van with me. And we'll get that set up. So once I have the furnace up, running, tested, and safe, we're going to take an overnight run up to Hancock Campground up in Lincoln, New Hampshire again. Right, hopefully still in February. And we're going to do a one-night trial run of the furnace just to see what it does. See how it does, things like that. Only 2 hours from home, something goes wrong, and I lose my heat, I can still get home pretty quickly without too much effort. But in the meantime, we'll give it a good trial run, test it out overnight. We'll make sure it's a night that's not too terribly cold. Not that this winter's been cold at all. I mean, today it reached like 60 degrees here in February. I'm kind of missing winter right now, but trying to take as much advantage of this nicer weather here to get some projects done on the van. But we'll get that tested out. We'll bring it up there, spend a night in the van, see how it does, and then we'll come home and see how much propane I used, how much power I used, and go from there. With that, I want to thank everybody for watching. I know this hasn't been an exciting project here, just rewiring the electrical system, but it's been a fun one. So it's been a couple weeks in the making here too. So and I'm making some phenomenal progress on it. So it's going to be much better trips this year. Things are going to be safer and working a lot better. So with that, remember, slow down and enjoy life, and we'll talk to you guys later.